Good morning, students. Today we are going to learn about Fourier series for even and odd functions. So now the question arises, what is an even function? What is an odd function? First of all, let us see what is even function and what is odd function. Even function. A function f of x is said to be even if f of minus x is equal to f of x for all x. Example, x square, x power of 4, cos x, sec x, all are even functions. So what is the definition of even function? F of minus x is equal to f of x. For example, if you take x square, f of 2 is 2 square, that is 4. F of minus 2 whole square, that is 4. So f of minus 2 and f of 2 both are equal. Not only for 2, for all x it is 2. F of minus x is equal to f of x for all x, then such a function is called even function. Cos of theta is equal to cos of minus theta for all theta. So if f of x is equal to cos x, then f of minus x equal to cos of minus x, that is also equal to cos x. Therefore f of minus x and f of x both are equal. Such a functions are called even functions. So what is an even function? A function is said to be even function if f of minus x is equal to f of x for all x. This is an even function. And coming to an odd function, a function is said to be an odd function if f of x is equal to minus f of x for all x. So that is f of minus x is equal to minus outside into f of x. Example, x cube sine x. Here you can take mod x also. Example, all mod functions are even functions. So this is about even and odd functions. So what is an even function? If f of minus x is equal to f of x for all x, then such a functions are called even functions, and odd function is f of minus x is equal to minus into f of x for all x, then it is called odd function. So this is even and odd functions. Examples for even function is x square, x power of 4, x power of 6, x power of 8, cos x, sec x, mod sin x, mod cos x, all are even functions. And f of minus x equal to minus into f of x for all x is called odd function. And examples for odd function are x power of 1, x cube, x power of 5, sin x, cosec x, and so on. All are odd functions. So what you are going to learn today? You are going to learn what is Fourier series for even function and what is a Fourier series for odd function. So let me put in aeroplane mode so that no disturbance comes. So this is what is even and odd functions. Now let us see Fourier series for even and odd function. Up to now what we said, in first class we defined a Fourier series and we are able to find Fourier series for different functions. Examples, we did f of x equal to x, f of x equal to x square, f of x is equal to sin x, f of x equal to e power of x, f of x is equal to x into sin x, f of x is equal to x into cos x. For all such functions we are able to find Fourier series. Now next what we did, we are able to find Fourier series for discontinuous functions. Discontinuous functions means throughout the interval f of x has not having the same value. So that's why we divide the integral into two parts to find the Fourier series for discontinuous functions. We covered yesterday. Now what you are going to learn? Today class we are going to learn about how to find Fourier series for even and odd functions. So we defined even function with an example and we defined odd function with an example. Now let us go to the Fourier series for even and odd functions. Fourier series for even function. Fourier series for an even function in an interval minus pi to pi. So even function or odd function you have to define only on minus to plus. So this is the important point to note whenever we are giving a Fourier series for even or odd function, then interval is from minus to plus. Here example you are having minus pi to plus pi. So for even function, what is a Fourier series? F of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n into cos n x. F of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity. F of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n into cos n x. No bn term. In even series, for a even function, the Fourier series, no bn term. Only a naught and a n comes. So it is enough to find a naught and a n if the function is even in the interval minus to plus. Remember, the interval should be from minus to plus. Here minus pi to plus pi. So we learn all our problems are from minus pi to plus pi. Interval you have to look after first of all whether before the given function is a even or odd. First of all the interval is must be minus pi to pi, then only you can go on. So if the interval is minus pi to pi and given function is an even function, then Fourier series for the given function f of x is a naught by 2 plus sigma n is equal to 1 to infinity a n into cos n x. No bn term at all. So what is a naught value here? Slight change in the formula. A naught is equal to 2 by pi integration 0 to pi f of x into dx. Whereas a n is 2 by pi integration 0 to pi f of x into cos n x dx. So formulas are same. Interval instead of minus pi to pi we will write 0 to pi multiplied with 2. So this is an extra. In Fourier series we got 1 by pi and even or odd functions we will get 2 by pi. So this is a Fourier series for even function. The interval must be on minus pi to pi. Then for even function there is a no bn term, only a naught and a n terms. And what is a naught formula? It is 2 by pi integration 0 to pi f of x into dx. A n formula 2 by pi integration 0 to pi f of x into cos n x dx. This is a Fourier series for even function. So it is reduced only two terms, a naught and a n values enough to find no bn term in even function. Are you able to get it? In a even function there are no bn terms, only a naught and a n. That's it. There is a slight change in the formula to be noted. You will get 2 by pi. That is enough. This is a Fourier series for even function. Now Fourier series for odd function. Fourier series for odd function on an interval. So you have to note down the interval for even or odd function. The interval should be minus pi to plus pi only. On 0 to pi it cannot be. C to C plus to pi, no. Only the interval must be from minus pi to plus pi. Then only we can go for odd and even function. This is the first necessity. And if the function is odd function, then Fourier series is f of x is equal to sigma n is equal to 1 to infinity bn into sin n x. No need to find a naught or a n. No a naught a n terms. Only bn terms. So the problem is reduced. Are you able to get it? In a Fourier series you will get a naught, a n and bn term. But if the function is even function, then only a naught and a n terms. And if the function is bn, function is odd function, then only bn term. So what is a bn here? Bn is 2 by pi integration 0 to pi f of x into sin n x dx. So interval is minus pi to pi, but we will write 0 to pi and multiplied with 2. That is a change in the formula. In a Fourier series, initially we have the formula 1 by pi, but in even and odd it is 2 by pi, and interval is minus pi to pi, but limits are from 0 to pi, not minus pi to pi, it is 0 to pi. That's why it is multiplied by 2. So what is a Fourier series for odd function? F of x is equal to sigma n is equal to 1 to infinity bn into sin nx, where bn is 2 by pi integration 0 to pi f of x into sin nx dx. So this is our Fourier series for odd functions. So in this class we are going to find Fourier series for even and odd functions. So first of all we define what is even function and what is odd function, and we are given now Fourier series for even function and Fourier series for odd function. So first point to be noted in finding a Fourier series for even and odd function is that the interval is from minus to plus. And second point is noted, if the function is even function, only a naught and en terms exist, no bn term. And if the function is odd function, only bn term exists, no a naught and an term. So the problem is reduced. No need to find three values a naught, an, bn. Only in case of even, only first two a naught and an, and in case of odd function only the last term, that is a bn. That in this way problem is reduced for even and odd functions. Are able to get it what is a Fourier series for even function and what is a Fourier series for odd function. Okay, so let us go to the problem, students. I already said you we are going to cover as many problems as possible in this video classes, online classes, because many of you are not having materials. So we are able to cover. We are going to cover more problems and we are going to give less problems as a homework. So let us go to the problems now. So before going to problems, one thing I want to recall you: sine 0, sine pi, sine 2 pi, sine 3 pi, sine 4 pi, sine 5 pi, sine 6 pi, all are zeros. In general, sine n pi is 0. That's what you have to remember. And the second one is cos 0, cos 2 pi, cos 4 pi, cos 6 pi, cos 8 pi, cos 10 pi, all 1. So cos 2n pi, even multiple of a pi, is always 1. Whereas cos 0, 1, cos pi, minus 1, cos 3 pi, cos 2 pi, 1, cos 3 pi, minus 1, cos 4 pi, 1, cos 5 pi, minus 1, cos 6 pi, 1, cos 7 pi, minus 1, alternately plus 1, minus 1. Therefore, cos n pi is minus 1 all power of n. This is already I told you in previous classes repeatedly. Now also I am recalling it because we will use cos n pi is minus 1 all power of n, whereas sin n pi is 0. So let us go to the problems. Find the value of a naught for f of x is equal to x in minus pi to pi. So see that the interval is minus pi to pi and the function is odd function. For odd function only bn exists, no a naught and an. So what is a naught value? Since it is a naught function f of x equal to x is an odd function, therefore a naught value is 0. No need to find at all, since given function is odd function and interval is minus pi to pi, therefore only bn term exists, no a naught and no an. A naught and an are zeros. This is one mark question, previous question for 1 mark. Find the value of bn where f of x is equal to cos x in minus pi to pi. Again the interval. See the interval, it is minus pi to pi, and see the function cos x. Cos x is an even function. Clearly f of x equal to x. Cos x is an even function. For even function only a naught and an terms exist. No bn term, therefore bn is equal to 0. That's it. For 1 mark you are able to get this such a type of questions. Are you able to get it? For a even function, only a naught and an no bn term, bn is 0. For odd function, only bn term, no a0 and an, a0 an equal to 0. So in that case, in this concept, it is given for 1 mark. Are able to get it very easy. Let us move on. Let us move on to the problems for the essay questions. These are 1 mark questions on concept of even and odd functions. Now let us move on to the essay questions. 5 marks questions. In semester end exams, damn surely you will get it. All problems that we are going to do are all previously many times repeated questions. And as there are 30 minutes to go, so let us firstly move to the problems. Yes, this is our first problem. Express f of x is equal to x as a Fourier series in minus pi to plus pi. So the problem to be noted is, what is the problem? The interval is minus pi to plus pi. What is an interval? It is minus pi to plus pi. And what is a function? What is a function? It is x. X. Clearly x is an odd function. Clearly x is an odd function. So a0 value 0. An value again 0. So what we have to find? We need to find only one term, that is bn. We need to find only bn term, because the interval is minus pi to pi and the given function f of x is equal to odd functions. Therefore, we need to find only bn term in order to find Fourier series. So, what is the Fourier series for odd function? X is equal to sigma n is equal to 1 to infinity bn into sin nx. Let us find bn value here so that you can find the Fourier series. What is bn? Bn is equal to 2 by pi integration 0 to pi f of x into sin nx dx. This is a formula, just variation. Though the interval is minus pi to pi, we write limits 0 to pi multiplied with 2. That is 2 by pi integration 0 to pi f of x into sin nx dx, where f of x is x. So 2 by pi integration 0 to pi x into sin nx. So Bernoulli rule, product of two functions x into sin nx. X is an algebraic function, sin nx is a trigonometric function. As per Euler rule, x comes first and sin nx comes next. Therefore, x is the first function, sin nx is the second function. Now, x derivatives 1 and 1 derivative 0, sin nx integration minus cos nx by n and further integration minus sin nx by n square. By Bernoulli rule, cross multiply plus and minus, what you will get? First term minus x cos nx by n, second term plus sin nx by n square, but sin n pi values is always 0, so sin term is 0 for sin pi and sin 0, so only pi term, apply pi, minus pi into cos n pi. Cos n pi is minus 1 whole power of n by 0 by n, plus sin term is 0. Now lower limit 0 into something 0, so lower limit values are 0, no need to take, and pi cancel here. So answer is minus 2 by n into minus 1 whole power of n. Minus into minus 1 whole power of n is minus 1 whole power of n plus 1. So this is the answer for Bn. Bn is equal to 2 by n minus 1 whole power of n plus 1. So given function is an odd function and given interval is on minus pi to pi. So only we need to find only Bn term. Now we got Bn term in a Fourier series. Only Bn term exists. See, I am boxing it. Only Bn term exists. X is equal to sigma n is equal to 1 to infinity Bn into sin nx. Because for odd function a0 and an values are 0. Only Bn term. Now we are able to find Bn 2 by n minus 1 whole power of n plus 1. Now substitute in a Fourier series to get a Fourier series for an odd function f of x is equal to x. So let us substitute now this Bn term. Note it down so that we can move on to substitute this Bn term to get a Fourier series for an odd function f of x is equal to x in minus pi to pi. So this is a Bn value we got 2 by n minus 1 whole power of n plus 1. This is a Bn term. Let us substitute in the Fourier series to get the Fourier series for given odd function in the interval minus pi to pi. So now Fourier series is x is equal to 2 constant outside, sigma n is equal to 1 to infinity minus 1 whole power of n plus 1 by n sin n(x). So you have to substitute n is equal to 1. N is equal to 1 means minus 1 whole power of 2 plus 1. So sin x by 1. N is equal to 2 means power becomes odd, therefore minus 1 by 2 sin 2x plus 1 by 3 sin 3x minus 1 by 4 sin 4x. Alternatively, plus minus comes. So what is a Fourier series? For a function f of x is equal to x, which is an odd function in an interval minus pi to pi. What is that? X is equal to 2 into sin x minus 1 by 2 sin 2x plus 1 by 3 sin 3x minus 1 by 4 sin 4x and so on. Alternatively, plus minus comes. So this is a Fourier series for a given function f of x is equal to x, an interval minus pi to pi. Note it down so that we can move on. So we covered one problem which is an odd function on interval minus pi to pi. Another 25 minutes ago. So let us try to cover more problems. So next problem is, what is the next one? Expand f of x is equal to x square as a Fourier series in minus pi to pi. Students, note that what is an interval? A given interval is minus pi to pi. So the first essential thing, the interval is from minus pi to pi, that is you have to be noted. So the first interval is minus pi to pi and function is x square. What is an x square? X square is an even function. Since given function is even function and given interval is minus pi to pi, so as for Fourier series for even function on minus to plus, what is a Fourier series? Fourier series is f of x is equal to a naught by 2 plus sigma a n into cos n x. So only a naught and a n terms, no b n term at all. No b n term, only a naught and a n. Two things be noted. First thing, that the given interval should be minus pi to plus pi, and the second thing is the function is odd or even. If it is odd, only bn, and if it is even, only a naught and a n. So if it is neither even nor odd function, neither even or not odd, it's just like x plus x square. This is neither even function nor odd function. If it is not even not odd, then you have to find a naught, a n and b, and same formula you have to go for, and intervals minus pi to pi and limits also minus pi to pi. Only if the interval is minus pi to pi and the given function is odd function, find bn term. Or if the given function is even function, then find a naught and a n term. Now the given function f of x equal to x square is an even function and the given interval is minus pi to pi. So we should find Fourier series. In Fourier series we will get a naught and a n term. So what we are going to do now? We are going to find a naught value and a n value, then substitute in a Fourier series, that gives answer. So let us go for this. Is the Fourier series for even function. F of x is equal to, that is x square is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n into cos n x. So now let us find a naught and a n value. So what is a naught value? As for formula, it is a even function formula. Instead of 1 by pi, what you are going to get? 2 by pi. Instead of limits minus pi to pi, you have to write 0 to pi. So what is a naught? A naught is equal to 2 by pi integration 0 to pi f of x into dx. That is 2 by pi integration 0 to pi. What is f of x? F of x is x square into dx. So x power of n integration is x power of n plus 1 by n plus 1. Therefore x square integration x power of 3 by 3. 3 is a constant outside, 2 by 3 constant upper limit minus of lower limit, that is pi cube minus 0 cube. 0 cube is 0, pi and pi cancel, a naught is equal to, what is a naught? A naught is equal to 2 pi square by 3. So this is what we got. Now we are able to find a naught. Now let us go to an value also. Are you able to get it? I will erase this. Please note it down. Given function is x square, even function, and given interval is minus pi to pi. Therefore, you can ask for Fourier series of even function. Now the Fourier series consists a naught and an value. Therefore, find a naught and an and substitute in a Fourier series. That gives answer. Now you are able to find a naught. What is a naught value? 2 pi square by 3. Note it down. Let us go to an value also. We are able to find a naught. Now let us go and find an also. Make it fast, only 20 minutes to go. So let us go for an value right now. What is an formula? As for formula, what you are having? 2 by pi integration 0 to pi f of x into cos n x. Point to be noted, interval is minus pi to plus pi, but the limits are 0 to pi multiplied by 2. So the formula, what is the formula of an is? The formula of an is 2 by pi integration 0 to pi f of x into cos n x. What is f of x here? F of x is x square. So it is x square into cos n x. Product of two functions, integration 0 to pi x square into cos n x. Apply Bernoulli rule. What is x square? X square is an algebraic function and cos n x is a trigonometric function. As for isolate, x square algebraic function first and cos n x trigonometric function second. Therefore, the first function is x square and the second function is cos n x. For x square, we need to find derivatives, and for cos n x, we need to find integrals. X square derivative 2x and 2x derivative 2 derivative 0. Cos n x integration sin n x by n and sin n x integration minus cos n x by n square, and further integration minus sin n x by n cube, alternatively plus minus plus cross multiply to get 2 by pi. First term x square into sin n x by n, second term 2x into cos n x by n square, plus into minus minus 2 sin n x by n cube. The point to be noted here is the sign terms is always 0 because sin n pi is 0. So the first term values for upper and lower limit and last term values from upper and lower limit are 0. Only middle term you have to do, that's it. So for upper limit pi, first and last term 0, the middle term 2 into pi cos n pi. Cos n pi is minus 1 whole power of n by n square, and for lower limit 0, 0 into something 0, 0 into something 0. Since it is sin, the lower limit value is 0. Pi and pi cancel, 2 into 2 4, 4 into minus 1 whole power of n by n square. This is, we got an term. Now we got an. Let us move on to, and we are able to find a naught and an. Now substitute these values in a Fourier series of even function to get the Fourier series. So note it down so that we can move on to the next one. So this is, we got an by using Bernoulli rule, x square into cos n x, where x square is algebraic function and cos n x is a trigonometric function. So x square is a first function and cos n x is a Second function, for first function x square find derivatives, and second function cos nx find integrals. Cross multiply with plus minus, that is a Bernoulli rule, but in cross multiplication we got first and third terms are sin x, those values are 0 for any pi, so only middle term you have to concentrate. Hence we got a n is equal to 4 into minus 1 whole power of n by n square. So what we got? We got a naught equal to 2 pi square by 3, and we got an is equal to 4 into minus 1 whole power of n by n square. So let us substitute in a Fourier series. Excuse me. Fourier series is f of x is equal to a naught by 2 plus sigma a n into cos nx. Now substitute a naught. What is a naught? 2 pi square by 3, and a n. What is a n? 4 into minus 1 whole power of n by n square. So substitution 1 by 2 into 2 pi square by 3, 4 constant outside, sigma minus 1 whole power of n square by n, 2 and 2 cancel in first term. Now f of x equal to pi square by 3, substitute n is equal to 1 to infinity, minus 4 into sigma n is sigma minus 1 whole power of n plus 1 by n square cos nx. For n is equal to 1, it is cos x, n is equal to 2, it is minus 1 by 2 square into cos 2x plus n is equal to 3 plus 1 by 3 square into cos 3x. Therefore, for x square, what is Fourier series? For x square, the Fourier series is pi square by 3 minus 4 into cos x minus 1 by 2 square into cos 2x plus 1 by 3 square into cos 3x. Are you able to get it? Here we are writing minus, and the power is increased. One power is increased. So minus 1 whole power of n into minus is minus 1 whole power of n plus 1. So this is a Fourier series for an even function f of x equal to x square in interval minus pi to pi. Many times repeated question for 5 marks. Point to be noted is all the questions what we are covering are previous questions for 5 marks. So what is this? This is a question. Expand f of x equal to x square as a Fourier series in interval minus pi to pi. The interval is minus pi to pi, and function is x square is an even function. Find a naught equal to 2 pi square by 3, a n is equal to 4 into minus 1 whole power of n by n square. Substitute a naught and a n values to get a Fourier series for even function. Note it down so that we can go on to the next problem. Okay. So another 15 minutes more, so you can go for next problem. So let us go to the next problem. Expand f of x equal to mod x as a Fourier series in minus pi to pi. So see the function and see the interval. The function, the interval is minus pi to pi. First essential thing is the interval should be minus pi to plus pi. And the second one is the function is a mod. All mod functions, mod x, mod cos x, mod sin x, mod x square, mod x cube, mod tan x, mod sec x, whatever you take, mod functions are even function. So given function f of x equal to mod x is an even function and give on the interval minus pi to pi. So both are said. The interval is minus pi to pi and the function is even function. Excuse me. Now, so what is the Fourier series for even function? The Fourier series for even function is mod x is equal to a naught by 2 plus sigma a n into cos nx. as it is an even function on interval minus pi to plus pi. Therefore, no bn term, only a naught and an terms. That's why the Fourier series for even function mod x is given by how it is given. Mod x is equal to a naught by 2 plus sigma an into cos nx. Now let us find a naught value and an value, then substitute here to get the Fourier series. So first of all, a naught. What is the formula of a naught? A naught is equal to 2 by pi integration 0 to pi f of x into dx. What is f of x? Mod x. So a naught is equal to 2 by pi integration 0 to pi mod x dx. Now coming to mod x. If x is positive, mod x is equal to x. If x is positive, what is a mod x? Mod x is equal to x. And if x is negative, mod x is equal to minus x. Now, what is interval here? The limits of the integration are 0 to pi. 0 to pi greater than 0. Greater than 0 means it is positive. For a positive, mod x is equal to x. So, what is the next step? 2 by pi integration 0 to pi at place of mod x, you can write x into dx. X power of n integration, x power of n plus 1 by n plus 1. Now x power of 1 integration, x power of 2 by 2, from 0 to pi, 2 cancel. So in x square, upper limit minus of lower limit, that is pi square minus 0 square. 0 square is 0, pi square minus 0 is pi square, 1 pi cancel. So what is a naught value? A naught is equal to pi. In box I written. I given a red mark also. What is a naught? A naught is equal to pi. Are you able to get? The point, the interesting point here is definition of a mod x. The new point is, what is a mod x? Mod x is equal to x if x is positive. For x positive, mod x is always is equal to x. And for x is negative, then mod x is equal to minus x. So mod x is equal to x for x is positive, mod x is equal to minus x for x is negative. So here x values are from 0 to pi. The limits of integration are 0 to pi. So mod x is equal to x. X integration x square by 2. Apply upper limit and minus lower limit to get the answer. A naught is equal to pi. A naught is equal to pi. Now we have to find an. Note it down so that let us go to an value. An. What is the formula for an? An is equal to 2 by pi integration 0 to pi f of x into cos nx dx. What is f of x? Mod x. So 2 by pi integration 0 to pi mod x into cos nx dx. So in previous slide only I told you what is mod x. Mod x is always x for x positive and mod x is negative for x negative minus. Are you getting? Mod x is equal to x for x positive and mod x is equal to minus x for x negative. Here limits are 0 to pi. Therefore mod x is equal to x. X into cos nx. X into cos nx. Product of two functions x into cos nx. You have to apply Bernoulli rule. What is x? X is an algebraic function. What is cos nx? Cos nx is a trigonometric function. In a rule highlight, a comes first, t comes next. That is, x algebraic function becomes a first function and cos nx trigonometric function becomes a second function. For first function, we need to find derivatives and for second function, we need to find integrals. X derivative 1 and 1 derivative 0, cos nx integration sin nx by n integration minus cos nx by n square, cross multiply plus minus to get the first term x into sin nx by n, second term cos nx by n square. You know sin n pi is always 0, so first term for upper and lower limit it becomes 0. Only the second term you have to concentrate. Cos n pi is minus 1 whole power of n by n square. First term 0, second term minus 1 whole power of n by n square, and for lower limit first term 0, cos 0 value is 1 by n square. So take LCM n square. So what is an value? An is equal to 2 by pi minus 1 whole power of n minus 1 by n square. So this here we are able to find a naught, and now you got an also. So what is the points here? Mod x in 0 to pi it is x, because 0 to pi is a positive. So first term that. Second one is x into cos and x product. Integration of product means you have to apply Bernoulli rule. In a Bernoulli rule you have to decide which is the first function and which is the second function. Take the rule of isolate. In a isolate, a is a third and t is a fourth. So a algebraic first and t trigonometric fourth, second. So x is an algebraic function, that is a first function, and cos nx is a trigonometric function, that is a second function. So find derivatives of x and find integrals of cos nx, cross multiply plus minus, that is a Bernoulli rule. Apply Bernoulli rule, then upper limit minus of lower limit. Here the point to be noted is sin n pi is 0. So first term which contains sines is 0 for upper and lower limit, and cos n pi is minus 1 whole power of n, and cos 0 is 1. So that applying all this you are able to get an is equal to 2 by pi minus 1 whole power of n minus 1 by n square. So we are able to find a naught value and we are able to find an. So what is a naught we got? A naught is equal to, we got pi, and an is equal to, we got 2 by pi minus 1 whole power of n minus 1 by n square. Note it down. Let us go and substitute this a naught and an values in a Fourier series to get a Fourier series of even function f of x is equal to mod x in an interval minus pi to pi. So make it fast, only 5 minutes for, I think, as no more time. Now let us substitute a naught and an values in the Fourier series. What is a naught? A naught we got, a naught it is pi, and what is an? An is 2 by pi into minus 1 whole power of n minus 1 by n square, that is an. Now substitute a naught and an terms in a Fourier series. Fourier series, mod x minus pi to pi, it is an even function. So mod x is equal to, what is a naught? It is pi. So pi by 2 plus 2 pi pi into sigma n is equal to 1 to infinity minus 1 whole power of n minus 1 by n square into cos nx. Now substituting a naught and an terms in a Fourier series of even function, we got mod x. We got mod x is equal to pi by 2 plus, so what we got? We got mod x is equal to pi by 2 plus 2 by pi into sigma n is equal to 1 to infinity minus 1 whole power of n minus 1 by n square into cos nx. That is our mod x. Now substitute n is equal to 1 to infinity. For n is equal to 1, you got minus 2 by 1 square into cos x. And for n is equal to 2, it is 0. For n is equal to 3, minus 2 by 3 square into cos 3x. For n is equal to 4, it is 0. And n is equal to 5, minus 2 by 5 square into cos 5x. So what you are able to get it? For n is equal to 2, n is equal to 4, n is equal to 6. For all even n values, the values of sigma are 0. So what is a Fourier series for mod x is pi by 2 minus 4 by pi into cos x plus cos 3x by 3 square plus 5x by 5 square and so on. So this is our Fourier series for the function mod x. Mod x is equal to pi by 2 minus 4 by pi into cos x plus cos 3x by 3 square plus cos 5x by 5 square and so on. So we are able to cover 3 problems here. Shall we go to the 4th problem? But I think the time is as what is the time left is only few minutes. So these lengthy problems we cannot take the lengthy problems with a few minutes. It takes at about 10 to 12 minutes for each problem. So we are able to cover the 3 problems. All our previous problems, what we covered, f of x is equal to x minus pi to pi interval odd function, f of x equal to x square on minus pi to pi, it is an even function, and f of x equal to mod x on minus pi to pi, again an even function. So one example an odd function and 2 examples an even function, and all these 3 questions are very important because they are repeatedly came in a semester end exams for 5 marks. So students, practice these 3 problems again and again. Practice well, then go to homework problems. So let us give now homework. So let us go to the homework. Okay, homework, note it down. Homework problems for today. The first one is obtain a Fourier series for f of x is equal to mod cos x in minus pi to pi. All mod functions, whatever there is in the mod, all are even functions. Mod x square, mod x cube, mod sin x, mod cos x, mod tan x, whatever you take in the modulus, that is an even function. So your f of x equal to mod cos x is an even function in an interval minus pi to pi. Therefore only need to find a0 and an value, no need to find bn. So second question is obtain Fourier series for f of x equal to mod sin x in minus pi to pi. Again mod, therefore it is even and interval is minus pi to pi. So first of all you have to look the interval minus pi to pi and then the function. Here the interval is minus pi to pi and function is modulus. Therefore it is an even function on minus pi to pi. Therefore you can apply even Fourier series for even function. There only a0 and an terms, no bn term. And if it is odd on interval minus pi to pi, only bn and no a0 and an. So that is your homework. Students, practice the 3 problems that covered in this video lesson and then go and do the homework problems and submit in a Google Classroom. Yes, for any queries, you can mail me at naresh.debadi@gmail.com. You can also post in our Google Classroom also. So substitute your homework in Google Classroom so that I will give a quick response and verify your homework. And any queries you can mail me or you can post the thing in Google Classroom also. So this class, what you learned in this class. So what we learned is, we learned about Fourier series for even and odd functions. For even functions, only a0 and an terms, no bn term, and for odd functions, only bn term, no a0 and an term. The point to be noted is, what is essential is, the interval should be from minus pi to pi. So whenever even an odd function we are going, then the interval should be minus pi to pi. So this is what covered in this class. Thank you guys. Thank you very much. See you tomorrow with the off-range series. Thank you very much. See you tomorrow.